Appears to be live. Just do the usual testing and such, just to make sure. Mostly. Just for that purpose.
Appears to be live.
Okay, so we did that. Yes, no real agenda, just the Saturday morning thing. Attempt to do something every Saturday, but who knows? It's probably not a good idea because there's always something that happens. Like today, people came to look at the property and whatnot. And so, reliable time isn't really practical and all that kind of stuff. Anyway, so we'll just do some comments and then comment on some of the videos I've seen, and that'll be it, I guess. Mostly. Yeah. All right. So very nice guy. Long rider. Gary, I sent you a vape package. It had this thing in it. It's Phix, Phix. Incredibly handy, light. I imagine the batteries probably don't last more than, I don't know, I haven't tested it really, an hour, something, I don't know, but it's very nice. Everything's magnetic, it just pops apart, and very stylish and modern. Yes. So really good. I mean, as a more portable. I mean, this thing is quite heavy with the batteries in it. Heavy. So this, but anyway, just all this nice vape technology is really nice. So anyway, thanks. Very, will get used. Yeah, no doubt about it. Yeah, it's nice. Flavors and such too. Yeah. I don't usually do flavor, so it's kind of a nice change of the pace and whatnot. All right, so anyway, but yeah, I don't know what to say. Thank you. It's very thoughtful and such. Really, quite nice. Anyway, all right, nice vid. I haven't decided if Ken or you insult people better. But I think you're wrong when you say that particle wave duality doesn't apply at the same time. Well, I think you have no evidence really, and this crap you're going to link to is just absolute crap. I think it's just a silly notion of saying particles are anything like a wave. They aren't a solid thing. I mean, it just depends on what you want to do to the word wave. Again, I could throw these things at you. You could say you're waving them at me. No, I'm throwing them at you. It's not a wave. It's little individual things hitting you. At a rate that I throw them. It's not a wave of anything. It's not perturbations. It's not spreading. It's again, Feynman said. He didn't say, "What the fuck? It's not the wave." I mean, don't you idiots? Haven't you ever looked up wave in the dictionary? This stuff isn't waving, you idiots. It's not spreading. It's not it doesn't reduce with distance. It doesn't do any of the stuff waves do. Why are you calling it a wave? It's stupid. So, I mean, I don't know what to say. Prove it. And your proof is shit. We have a photograph of the photons. No, you don't. It's just so fucking retarded. All right, anyway. At least I wrote about an experiment on the net lately. I don't know what that means. At least I wrote about an experiment on the net lately. First off, this experiment is like 4 years old or something. I saw this stupid image like 4 years ago where they have claimed to actually have taken a photo. Yeah, you put it in quotes. So you actually get the idea that, that's sort of bogus and idiotic because it's not a photograph. Anyway, of light being both at the same time. And here's the link. So let's go to the garbage link. I think I have it open already. No, that's the other link. What's this one? That's an old holiday video. Ooh, weird. Okay, so here's the link. So we'll open the link. All right. For the first time first time ever photograph. So again, the word wave doesn't mean anything. They just blew that word up. And now they've blown up the word photograph. A photograph, by definition, is supposed to be made of photons hitting something. It's not supposed to be electrons hitting something. All right, it's not exactly the same thing in the first place. It's a synthetic image, and it's it's not even, yes, it's synthetic. It's not a real thing. This is not a real image of what photons are doing. You can't see photons with electrons. I mean, in any practical way, the photon is destroyed when it hits the electron. And so all you can see is photons emitted. You can't see what photons are doing. I mean, it's both particle and a wave. Now, in the first place, I'd say I don't see how this photograph indicates anything about that. Other than, look, they're lumpier in certain places. They have a lumpiness to the wave. Well, I guess the wave would imply lumpiness anyway. The up part and the down part, that sort of implies a lumpiness anyway. And obviously they don't spread sideways, so this synthetic image has just ordered them in the horizontal clump. So I don't even think that could mean anything. But again, it's not a photograph of it's electricity and a photomultiplier and an electron microscope. That's not how you take a photograph. I don't know. I really don't want to go into all the details of how the experiment was done, but it has nothing to do with taking a photo. So, this whole wave particle thing, though, it's got to be buried somewhere. You're going to have to commit to either living in your ether world, where everything is some sort of whatever coaxial cable, some sort of nonsense that you have these little special kind of waves that don't spread and they just go straight through some sort of domino field and all the dominoes flip just right or something. I don't know, whatever it is you want to make up your more complicated structure. So the structure of the universe is more complicated than the things in it. And you think that makes sense to you. It's like having a fishbowl made out of lions. It just doesn't make any sense. The thing you're holding the universe with is more complicated than the thing in the universe. Whatever. It's all right over your fucking heads. All right. So posting links with very little information is just kind of a dodgy thing to do. This link is useful. It's not really. First off, it's like 40 years old. The paper, 1960. I thought it had references. No, the references have the 80s in them. So somebody must have reprinted somebody else's article. So this is just another variation on Lesage gravity. I don't know exactly how this Lemonovsky guy has changed it any, but whatever. And it's just the same spiel about these fake problems, okay? And in here somewhere they deal with drag, but they deal with it in such a convoluted way that I don't even know what they're saying is the solution. It's got all this whatever, math that I don't think is saying anything in the first place. So it's a little bit, it doesn't sound like they're getting to the nuts of it. And the rest of the critiques are just nonsense. Obviously mock gravity works. They wouldn't call it mock gravity if it didn't work. So most of the criticisms are garbage, and the drag issue, again, from my attempt at trying to figure out this, there's this huge difference. Okay, you got the speed of light is, I think I've done 671 million miles an hour. So 671 million miles an hour compared to the speed of, say, let's gravity, which, if you could even get the maximum speed out of gravity per second, it would only be 22 miles an hour. So you have 671 million miles an hour compared to 22. So obviously, this amount of change in the pressure is really, really tiny. I mean, it's 26,000, well, I might as well say 27,000 to 1 in terms of a ratio. And so obviously, I think if somebody could, I mean, the problem with the argument, right? Feynman's, if you're running in the rain, more rain hits you in the front. Well, the problem with that analogy is it has no detail, because the point is in this circumstance, the rain is coming down really fast and you're moving relative to it incredibly slow. So there is some question. I'd say it's an open question about whether you could detect how much more rain you encountered, that you could measure the difference. And so I haven't found anywhere on the internet an explanation of how much drag there actually would be at speeds like, say, 25,000 miles an hour, which is like the fastest probe we can, anything in our local system. That's the fastest we can get anything moving. So, again, that's 26,000 times short, of what it needs to be. I think that's how I got that number, actually. Well, I have to think about what I did to get that number. Anyway, huge difference is the point. A tiny fraction of force difference in the pressure gradient that you're moving through. So that brings up the Pioneer probes again, which is they're experiencing a very slight, very small, going whatever, 30,000 miles an hour. They are able to detect a very slight, very small drag slowing down. So maybe the fact is that amount of drag would be consistent with the difference in pressure in a field that where the pressure moves, where you're moving faster than the pressure by 26,000 miles a second, or 1/26th of the speed of the pressure, one tiny percentage of the speed of the pressure. All right. So unfortunately, yes, this requires some way to calculate, to make that calculation. So I need to be able to make the calculation. What would the expected drag be if drag existed? So the people who argue that this drag problem has to be answered, they should at least point out how bad the drag would be, because no one's done that I can find. How many minutes, how many miles an hour degrade in something speed would be expected, I guess is the point. If the pressure field you're moving through is moving the speed of light, the bits that are hitting you. I don't know how else to say it, but that seems like a decent enough way to say it. All right, so I guess that kills the comments, which is pretty easy to do. Comments are weak, consistently weak. Yes, nice hiking vape. Yeah, as long as you don't lose it, I suppose. That's the problem with stuff that's really convenient, is you conveniently lose it. I don't like being called a bro, dude. So anyway, he says cool shirt, and yes, actually painted that, 20 years ago, 25, and such. Tried to make money selling art. Fuck, that was a horrible adventure. Anyway, shudder just thinking about it. Anyway, okay, so subscriptions, not much in the list here, so what I'll say what I can about the ones I saw. So the dissident Dave sort of did mention, sort of did acknowledge winning the whatever fuckwit award. Appreciates the mention anyway, so I will mention him. We do have a lot in common. I mean, I can't help but have some sympathies for Dave's position. We arrived on Earth a week apart, and we have no doubt some similar life experience. Some tiny bits. Anyway, but I just don't like this argument style. It's just too used car salesman for my taste, blah, blah, blah. So he did a video on black holes, and these arguments about black holes, obviously it really comes down to, for me, not whether or not might be heavy objects in space. Yeah, there could be really heavy objects that aren't on fire. No law against it. I would argue that with mass comes the problem of, like, the center of the Earth. The center of the Earth is molten and hot because of the very fact that the pressure creates that circumstance. And if you're going to heat heavy elements, just like heating helium or hydrogen, there's consequences. And so I don't think you can go over certain limits without things getting very funky in terms of what happens to that dynamic. So this whole idea of, black holes that weigh 2,000 solar masses or 2 million solar masses, it sounds a little fetched to me. But clearly, galaxies produce tremendous amounts of energy shooting out of them in different kinds of forms. And those bits of energy do appear to be coming out of, tiny locations. So, there's evidence on, lots of different kinds of evidence, but there's no clear anything. So, I just say that the idea of singularities or some kind of black hole that's, there's a whole universe in it or something, I think those are just silly arguments. So anyway, but it's not a terribly interesting subject. I just don't know why people keep going back to it. And the other one thing he keeps going back to is the Big Bang. I mean, who cares? If it's a repeating cycle, it's not a repeating cycle. It started once, it didn't start once. It's always been there, it's never been there. Who cares? I mean, it's just a subject I just don't see any point to. First off, because there's just not much evidence to go backwards. And the only evidence there is slight, in the sense that the further back you look, the universe does appear to look different. So the older light that we see, we think it's older. So that's the other problem. They don't really have a perfect system for telling how far away something is. They just have to go basically by how bright it appears to be. And, you can be quite far off just because of the size change. You just make the sun twice as bright and twice as big, and it appears twice as bright, and that could mean it's twice as close or twice as far away, depending on how you're interpreting your data. So, but yes, there does appear to be some sort of aging of the universe, in the sense that there was the quasar kind of idea. The little galaxies seem to be far, far away, and the big galaxies seem to be much closer. So there's some sense of aging with time. But who cares? The whole expanding thing is stupid, but that's a Redshift subject, which it does get a little bit interesting. And as I've sort of speculated, Redshift could be a consequence. The fact that things tend to get redshifted the further away they are, the more redshifted sort of implies, perhaps, that what's really happening is the photons, especially when they're looking at the spectral lines of, light. There's no spectral line for an individual photon. They can only see spectral lines when they sample a bunch of photons. So you can't see spectral lines by just collecting one or two photons. You have to collect a whole bunch of photons to fill in the spectrum, and to see that more light is red than less is blue, that kind of thing, or to see the shift in the spectral lines. So that means you have to collect a lot of photons from the same location. And my argument would be is that, in space, there still is little bits of stuff. And that little bits of stuff is going to be in the form of transparent stuff, like little light atoms. And like helium or hydrogen or oxygen or some other clear, quote unquote, atomically clear substance, atom. And if you hit one of those, they're good at coherently transmitting what they absorb. So the photon gets absorbed and it's retransmitted. And that's where the shifting is taking place, because there's obviously a capacity for that atom to change the frequency of the photons, the more than one little bit that has to go through that one atom. And it could change the polarization also. So that would be another interesting thing, is to see how polarized the light from distant stars is. But I'm just saying that obviously there could be a simple mechanism like that. Like, it's just the law of averages. The further away you go, the more likely the photon has gone through an atom or two. And by going through the atoms, it's subtly shifted by that process. Something like that. And then then their whole picture of the universe changes. But that's the problem with their picture of the universe, is that it's completely dependent on their assumptions going in. And there's a ton of assumptions. So I was watching something on neutrinos, 60 symbols video, just out of curiosity. It was in one of the related videos. And it was just horrible, because there really is a religion. I mean, the evidence of neutrinos is really weak. It was a mathematical prediction. And I don't even know how it could be mathematically predicted, in the sense that, how do you predict a maybe massless, maybe not massless particle, okay, produced when it's something less than a photon, right? I mean, it somehow has less integrity as a thing than a photon. So they're basically just broken, so if you go back to 1930, they had just finished doing this whole quantized thing, this whole idea of breaking things down into minimum packages of energy, minimums that you can't go below. And then all of a sudden now they're saying, no, we have something less than a photon. To me, that doesn't make any sense at all. How they even measure it as a component of energy. And their argument basically is we've mathematically decided that for there to be this helium reaction in the sun, where you convert hydrogen into helium, somehow the electron and proton, there has to be some interaction where you end up with an extra electron and an extra neutrino. So every time there's a conversion of a bit of helium in the sun, a neutrino is released, and neutrinos travel right through everything. So if you had, and it doesn't even make any sense. I mean, okay, so you have this mystery particle that's like a zillion times less substantive, that is less real, than a photon. Because, a photon gets stopped by, it doesn't take much lead for a photon, for all the photons to be blocked. Like you're really thin, paper thin. less than paper thin. But these neutrinos, you'd have to have a piece of lead that's like 600,000 light years across or something, a preposterous amount of distance. So they're like 6 billion times smaller than a photon. And I don't even see why they'd even invent something that small. We can't even measure the photon's energy with much reliability. And they think they can do something 6 million times or 6 billion times smaller. It just doesn't make any sense at all. I mean, it just sounds like complete nonsense. And they talk about it like, yeah, it's just, we have a ton of evidence. They don't have any evidence. They have no evidence. All they have is a theory where they put the talking bear into the story and it produces a conduit between two scenes in the movie. So it's like you have a perfectly rational movie you're making about some guy who works at a liquor store and his friend who works at the bowling alley. And so you need a plot device where the guy at the liquor store somehow finds out that the guy in the bowling alley is screwing his wife or something. And the plot device is you have a talking raccoon, that heard the conversation at the bowling alley, and he was an alcoholic raccoon. And so he was always going to the liquor store. And, you have a plot device. It just doesn't, it's a silly plot device. Neutrinos are a silly conduit between interactions. It just demonstrates that their theoretical construct has to be so bizarre for them to need a particle this absolutely meaningless. I mean, there's absolutely no role it could play. There's absolutely nowhere it could come from. It can't be made out of anything. I mean, it just doesn't play a role, a rational role, a reasonable role, one that can be explained. All right, so in that vein, the rational science guy did post a couple of videos. Not great, but when he's on this subject, he did 5 or 6 or 7 of these, hour-long videos, basically just going through gluons and quarks and the standard model, and just kind of mocking all these silly particles and all these silly explanations for how they're supposed to function. And it's a pretty good, in my opinion, a little bit redundant, but I mean, it's good in the sense of just pointing out, look how monstrous this model is they're using, where these things are 1 minute they're stretchy things, 1 minute they're bouncing things. They're, they've turned wave particle duality into wave glue particle, houseboat, they've almost anything. These things can be almost anything suited to your purpose. So if you need the car to be a submarine, it's a submarine. If you need the car to be an airplane, it's an airplane. I mean, it's transformers all over the place. Everything's a transformer. Nothing's a particle. Nothing's a thing. Everything's whatever I need it to be. They're all mutants with special mutant powers. Yeah, that's the other silly thing about the neutrino. The story was silly enough as just this weird, billion times smaller amount of energy than a freaking photon invention was bad enough. But then they decided that because they're not finding them, it must be because they have cloaks of invisibility. That is, they change color, and we can only see the blue color. We can't see the red ones, or some kind of crap like that. That they, yes, it's just Henry Potter all over again. I mean, they're just making this crap up. And it's crap, and it has the smell of just pulled out of an ass. I mean, it really does smell like it's just been ripe. It was pulled out of an ass, fresh. I mean, it just stinks. And it's just, and it's just bizarre that this is what smart people fall for, and the smarter people sell. And it just really embarrasses our intelligence as human beings that they get away with this crap, because it is crap. Steaming, made up fantasy crap. So in that vein, we're back to David, because he did this little spiel at the end of his talking video. His open room thingy, Friday Q&A thing, where he went on this little mush that it seems a lot of the dissidents do. They all seem to have an agenda where they all think there's this magical free energy out there, and free spirituality and free love and free all kinds of really great stuff will happen if we somehow get rid of the standard model, and accept one of their wacky theories. Then all of a sudden we're going to have all this free energy and free fun and free great stuff. So it does sound a little bit like they're forcing this, because they want the universe to be a different universe, that, they're trying to bend the universe into that different universe. They're bending the facts to try to point to that different universe. So I don't really see how David has any justification for that, just because a particle model doesn't create any notion of energy that's any freer than we already know it is. We already know nuclear energy is fairly free. It's just that it might kill you. It's free, but it's got poison in it, so to speak. It's full of radiation. So it's a free lunch that, unless you got the means to filter out the poison, it's a free lunch you really don't want to eat. That seems like enough yammering. Let's see if there's any comments worth the shit. What about white holes? Well, I don't even know what Shanny for Christ. That's pretty gross, frankly. The for Christ stuff is bad enough. But don't think so. Let's see. My testicles have doubled in size. I don't think it has. But anyway. Anyway, back to so that for Christ thing. You're just in the wrong room. So white holes. What's a white hole? That's supposed to be radiating the crap that was in a black hole. I don't see any evidence of any white holes. There's no real evidence of some star that's a billion times brighter than any other star. So white hole doesn't sound on the surface to be making much sense. And as I just pointed out, though, but clearly galaxies can produce these intense beams of radiation. Maybe that's a white hole event, but I would argue they're not really white holes then. They're just exploding somethings, not white nothings. So, just back to those kind of arguments that what are our expectations for how things explode in these different kinds of pressurized environments. So you could argue, like inside a galaxy, galaxies are flat, let's understand. So their gravitational pressure doesn't move in both directions, so to speak. It's mostly the pressure is moving in one direction. If you flatten the Earth, you could sort of understand that the part that would have the gravity, if you walked on this part, that would be the gravity part. But if you walked on this flat part, there wouldn't be any gravity, very little gravity. If you understand that the density of the material is what's causing gravity. And the reason why it feels consistent on Earth is only because the Earth is perfectly spherical. And that, when you do go on top of a mountain, it does change the gravity, which means kind of logically you can understand that, if that changes your gravity, then gravity has something to do with the diameter of the material. Whether you believe in Einstein or not, even under Einstein's theory, I suspect it's the distance from the center of the gravity. And as you change that distance, you change the amount of gravity there is. So, I mean, I'm just saying, so you can understand that if a galaxy has any pressure that it creates, it's all going one way. And that does sort of open a door in your logical brain saying that there's a tremendous amount of pressure going one way, pull on things. There's just one way. And that could cause some shearing with objects of certain sizes and all that kind of stuff. And, where they would end up exploding in a funny way, right? So if you have a pressure that's not spherical, then you can understand that if they're under a pressure that's not spherical, that when they explode, or if they explode, they won't explode spherically because they can't explode this way as much as they can explode this way. So it almost seems logical that if something explodes inside the center of a galaxy where the pressure would be the highest, logically, that thing, if it exploded, wouldn't explode this way nearly as much as it explodes this way, presuming the galaxy is flat this way. So anyway, that's just sort of logical, right? I mean, that's not, that's not asking too much, right? In a way of an inference, a logical inference that, I would not expect a flat thing, a flat grenade to explode the same way as a round grenade or something. That I would expect the fragments to fly off in a different way. And again, the point is we're not talking about just shape. We're talking about the shape indicates where the pressure lines are. And so that's going to have a, significant impact on how something will release its energy when it explodes. No, I think that's a perfectly reasonable explanation. Yeah, I think so. So anyway, yeah, there's not much I can do with this, whatever, doubling size of your testicle thing. They do seem to have a different size every day, it's my experience, but whatever. I don't know if they've ever doubled, though. I don't know if I've ever had a doubling. All right, so we'll do the 2-minute thing and see if anybody has anything to interject, play along, blah, blah, blah. If not, we will just keep it short and simple because, I don't really, I can just go over stuff I've already gone over, but I don't want to do that in just a random way. I don't think I do. I don't really think I want to do that. There's just so many things to, keep track of. So the Steve Burrows guy is still, he's getting close on the microwave experiment, at least parts of the experiment. I mean, obviously there's this technical problem of being able to detect just the energy of a radio signal rather than the, separating it out of all the other frequencies. So, being able to detect whether there's been jamming or not. And the only way you can detect jamming is to either make a directional antenna, one that only sees stuff, in a very, to narrow the cone of reception. So to create a device that nullifies, reflections and other stuff and just kind of gets, and then you could point it at something and say, see, the energy's still getting here from that location. And you probably can do that with radar to some extent, where all you have to do is, tilt it towards the one emitter at a time. So this way, just plain, you'd get no signal where the two signals are constructively interfering, right? No, destructively interfering. Yeah, so they're a little bit off the center where the destructive interference would be. One path is longer than the other path. And so you have no signal. But if you tilted the receiver and you picked up the signal, that would be a clear indication that there is in fact a signal. It's just that the two signals are interfering with each other in a sense that they're destroying the frequency of the signal. They're overlapping and creating a new signal that you're not tuned to, and therefore you can't receive it. So I've sort of made these arguments about this whole experiment, but I'm just saying they've used it to say like everything says, look, all the evidence points to waves, when no, all the evidence doesn't point to waves, and every one of these experiments is different. And this is what's sort of annoying about it, right? Because they use electrons and the photon experiment, and they kind of make them into the same experiment when you have to kind of know they're happening for, in some sense, different reasons. And that's why the patterns look different. Electrons hitting electrons, yes, that's going to be similar to a photon hitting a photon. So, I mean, a bowling ball, well, let's say a tennis ball hitting a bowling ball is going to be similar, or ping pong ball hitting a bowling ball is going to be similar to a pool ball hitting a bowling ball, but it's only going to be similar. It's not going to be the same. And clearly electrons, are actually producing radiation. So they bounce off each other's radiation fields. And fields are always, when a force exists, fields don't exist without the force being in the field. So, fields are force when they exist. When they don't exist, there's no force, quite obviously. So what was I going with that? Oh, yeah. So there's just lots of parallels to this thing where every time they try to make it into the same effect, where it's this quantum Heisenberg effect, when no, there's a different reason why the different things react to each other. And it's fundamentally different. And, they're not acknowledging any of that. And like I said, there are experiments that will end this stupid debate. Like all they have to do is when they use the buckyballs, when they use this carbon 60, 60 atoms of carbon, and when they shoot that through the experiment and get kind of a lousy pattern, actually, it's quite lousy. But it is a pattern. The fact is they could detect which slit those go through using photons. You can bounce a photon off 60 atoms without disturbing it too much. So they could detect what slit they go through. They could know for certain its position and its velocity. And those things can be measured with something that big. And that would end this whole nonsense that everything is Heisenberg. By their nonsense, you're not in a location. You're somehow in a bunch of locations. You're just a probability blob. And it just happens, that the camera looking at you, me, is imposing one me. But there's not really one me. It's just horse shit. It's so bad. I just don't know why I have to even argue. Their theory is so bad, so convoluted, made out of such thin, inaccessible evidence. All their evidence isn't like this. They don't have evidence like this. Screws fall to Earth because gravity, they don't have anything like that. They don't have an experiment like, wow, yeah, that's just so fucking obvious. They have intensely convoluted and complex experiments where there's just a whole bunch of assumptions about what's happening in all these little black boxes that they're sending this screw through. And they're giving you this theory that they've proven this screw can talk because, when they put it through this complex experiment, they claim they heard it say something. But the evidence is it isn't like talking screw evidence. There's no video of the screw talking. There's nothing. They call things, like I said, as the first beginning of this video illustrates, they call things photographs that aren't photographs. They just propagandize. They exaggerate preposterously and consistently. The most proven theory in the history of mankind, the most reliable mathematical formula ever contrived by mankind. Blah, blah, blah. It's just this intense exaggeration. So bad. So anyway, all right, let's see if there's anything else. I think the whatever it is, the other room thing they do on Saturdays, that's why I'm doing this, the CNPS thing. I think they're giving the room to the freaking creationist for the day. So that must be pretty bad. Oh, there we go. We have evidence that humans are dumb scum. Oh, yes. And he stole SpongeBob's name. I mean, that's just terrible to steal SpongeBob's name. So clearly, your mother was, raped by a retard, and your mother was in fact a retard, and that's why you can't find anything better to do with your pitiful existence. You pitiful pile of crap. Ugh. Kill them. Is there anything else? If somebody types anywhere on the internet, "Do you eat farts?" Why shouldn't they be killed? I mean, I'm just saying, as an argument, a logical argument, can we possibly go wrong? How could that be a mistake? To have a drone kill them, bomb them, whatever. How could it possibly be a mistake? How could civilization, American civilization, or any civilization on Earth, how could any one of them lose if that was international policy? I mean, just somebody who's going to defend the existence of these pieces of shit. I'm just saying, could you give me some indication of a rational argument how any human being on Earth's life will be degraded by the absence of people who type that kind of rubbish? Is there any probability study that these people could in any way have any capacity to do anything constructive ever? That the world will somehow be a better place with them than without them? Can you give me the logical argument, please? I mean, just you either defend civilization or you won't. If you want to have civilization, you have to defend it now and then. And it seems like all you people are just sitting here saying, "Oh no, that's not my problem." No, it's your problem. You won't have a civilization worth having if you don't defend it. And so I just like to hear the argument. Why aren't we defending our civilization? Well, I'm just saying that I could argue you're probably an example, though, right? I mean, but I have typed nonsense before. And have you ever typed anything that would say you have enough merit to justify the nonsense? That is, have you ever done anything that is truly valuable? And I might argue that you're just a defective. I'm substantially a defective, but here I'm doing this unification thing, and that's a pretty big fix for my defectiveness. But I'm just saying I haven't done any of this typing nonsense shit. I haven't done any of this saying nonsense shit. I don't understand why I would say or type nonsense. Why would I do that? I just don't understand. That's like shitting in a living room. I just don't know why I would do that. They said you eat farts on the gay forum. So I'm saying it's just, he has SpongeBob too. So he stole his name twice. Just horrible. But I'm just saying, why don't you, instead of doing this, why don't you just explain why you aren't scum? I mean, just, like some sort of putrid infectious bacteria that we shouldn't just fucking eradicate you. I mean, why are we sitting here playing with germs? You're a germ. Okay, you're not a human being. You're not an intelligence. You're not trying to be something good. You're just a germ. You're just a stupid little microbial bug, okay, that knows how to press keys on a keyboard. Ugh, pathetic. I'm just saying, it's a logical argument. I'm just saying, if you want a civilization, you have to do the minimums, people. And you're not even willing to do the minimums. You're just going to sit back and just let the Trumpers and the rest of the idiots in this planet take over and do all their work and just make the mess more putrid. And that's just so disappointing. Give it to the spammers and the fart talkers. fart typers. Anyway, give you a couple of minutes and then we'll go. I'll switch flavors. So easy. Just pull it out. Yeah. Put the little cover on it. Pick another flavor. And just magnetically pops in there. Supposed to be butterscotch, but it actually does taste more like Marlboro or something. It does, it does have a kind of a raunchiness to it that's just about right. Well, at least I'm getting to the job of blocking some useless accounts, so that's good. But I don't know why Google lets people do this. I mean, their algorithm can see people doing this kind of crap, and their algorithm just says, we don't care. This doesn't enhance the function of our software or our platform in any way. So somehow they think it's an enhancement of their platform that people, first off, can't open these rooms because they'll just let them get spam. Second, okay, that people in these rooms will have to waste time doing this. Like they should just have an insta block. I shouldn't have to open a menu to get rid of these people. There should just be a little red thing that just says hit the red dot and they're gone. I mean, this is just, they're just encouraging waste. I mean, why should anyone have to waste their time with this rubbish? Either blocking it or even reading it or any of it. Why? There's no good reason. They're all rotten reasons. Obviously, these people, there's these little scummy microbes. They must buy a lot of candy or something. Whatever Google's selling, these retards buy it. Cut your hair, sissy. I mean, amazing statement. When I could go through all like Cohan the Barbarian, right? One of the most unsissy movies. I mean, okay, it was a little gay, but I'm just saying it's, Arnold Schwarzenegger. I mean, I go through a list of just all kinds of movies where the strong hero has long hair. Just doesn't work as an argument. Booty. Booby. Oh, he's booby. Oh, yeah. Yes, that's what you have for a brain. Rancid boob milk. Ugh, disgusting. I'm not a booby man. Keep the Robert Plant look. Like he's the most famous person with long hair. I don't think so. I mean, when I was a kid, I was compared to Frampton, But I mean, the point is I actually have blonde hair, which is part of the joke, right? I mean, a lot of these other people are posers, right? They don't even have blonde hair. I mean, it actually grows out of my head this way. And it's kind of funny how I'm looking like them rather than them trying to look like me, right? They seem the ones they're trying, right? Because they're deliberately changing their hair where I'm not. I know who Robert Plant is. I'm just saying he's not exactly, he's not even Bon Jovi in some respects, just because he's like only artifacts, only people who are over 50, would have your, I mean, you're more gap than me, I guess, in not recognizing that Robert Plant hasn't been news for 30 years. And he was barely news then, in my opinion, or whatever. I mean, obviously, I've had the same hair for my, all my adult life. You know, I mean, I stopped having my hair cut when I was like 16. And I only had two haircuts, I think, after that. When I'm just because I was working at a restaurant that was a little bit, they obliged me to have some sort of style of hair. So I had it styled. But I just let it grow out, and they finally got used to me the way I was. Um, but yeah, I don't cut it. I don't do anything to it ever. This is what it does, and I'm fine with that. It's funny that this is the kind of thing that is important to people somehow. And I guess it's funny too, just because I guess it's part of this. Everybody is so hairless now. I mean, it's the hairless generation. I mean, bald men and shaved vaginas and all that kind of stuff. So it's people are very hair repulsed, I guess now. It's just very different from the world I grew up in, where you want to find a hot chick, you go to like Anne Margaret when she had her hair as wild as it could be. I mean, it was just so fuckable, and so it's just a different world. You are famous at my local school. I don't know. Where would that be exactly? Just curious. Yeah. My physics teacher considered your theory interesting. Well, then you would think he would have said something encouraging somewhere and said, "Hey, keep up the good work." But I don't think he has. You're from Los Angeles. Okay, that's not exactly the intellectual capital of the universe, but you know, and by local school, I don't know what I guess you're saying a high school. I don't think they really teach physics in grammar school. Well, yeah, they do. That's right. I mean, I took physics in seventh grade, I think, seventh and eighth grade. Yeah, I did physics. Yeah, that's when I did the cloud chamber. Frankly, I did better physics in grammar school when I think about it than I did in high school. The physics in high school sucked, but that's because it was all mathematics. Like the physics in grammar school was all demonstrations, stuff, carts moving, falling things, fire, it was all made out of real stuff. We actually looked at a little cloud chamber and watched little fucking swirly bits fly off. Um, where, high school physics, yeah, it was all math, angle of reflections, angles of this, blah, 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 all that fucking bullshit. So, yeah, it was just totally uninteresting. I mean, we had lab tables. I don't think we ever did a lab. I don't think we ever did any kind of experiment that could possibly mean anything. Bent space is worse than I would say, you know, any of those things you can compare it to. I mean, bending nothing is as bad as it gets, in my opinion. So they don't even have the balls to say bent ether, right? Because it would have to be some kind of ether they're bending. It has to be a something. You can't bend nothing. I mean, that's retarded. So they're ballless in so many respects. I mean, they're just not even owning up to their theories requires an ether, and in a sense that's what they're doing with quantum mechanics, is creating an ether, because everything's turned into a wave somehow. Everything's waving, so even though they call it a virtual photon, they might as well call it a virtual waveaton, because they really don't believe that photons are in any way um, meaningful. So the fart talker was disguising himself as a Los Angelian. Yeah. I smelled what was coming. Yeah, it really is. It is kind of a thing to marvel at. It's just the fact that this is what you get on the internet when you open a room called Talk Physics. This is what shows up. Yep. It's just yep, just yelling, it's just screaming. Oh, humans are such fail. But I will endeavor to persevere and assume that out there somewhere is an audience. Just hasn't found me yet. The audience I deserve, so to speak. Fellow truth seekers. Sick of the bullshit. Sick of pretentious, arrogant storytellers. What are your thoughts on supercooled gases? I don't like the whole conversation of below zero stuff. So that's really irritating. There's no way you do that. Like the Bose-Einstein condensate. That whole Bose-Einstein thing is again, that's more mathematical um, nonsense built on assumptions about what energy is. So I would argue that because they don't understand protons and electrons realistically, they don't understand how it's working, that the two are absorbing each other's energy. They're dispensing with it, essentially. They're evacuating the energy. And so the proton, and they think when you move two protons close together, you've created high pressure, because they don't realize that the reason why the protons get close together is because there's an electron, the neutron, that is letting all the energy out. So it is not a strong force. It's in fact a very weak force and very little energy. So everything they think is going on isn't right, because they don't really understand the fundamental nature of the function. So, see how to say that another way. And that the real pressure of the atom is in the fact that there is all of these, just like it's all magnetic tension. But the real pressure is between the electrons. Those are the bits that get pressurized. They're the ones being forced together, not the protons. So 7 sock accounts, and this guy is still going. 7 so far, just in this one, um, you know, encounter. 7 fake accounts, 7 troll accounts, allowed to be created just for this stupid purpose of saying the word fart. Doesn't make much sense. Exactly. It's just electrical conduction without loss from resistance. So when you cool something, I've sort of pointed that out, is you're taking all this noise out. So you're taking vibrations out, obviously. You're taking all the movement out. And so potential for things to go wrong ways. And there's certainly less potential for things to get lost, in the sense the thing is vibrating so much that the photon gets broken in pieces and the pieces fly out. So you're not going to radiate a bunch of your energy. The energy is going to get from point A to point B without any losses. So you'll just realize the more magnetic effect because you're not losing current. And you also greatly increase the amount of current you can pass through it because you're not heating the substance, and therefore you're not breaking it down and destroying its capacity to carry current. Probably a good way to say this, but it's like changing a steel rod into a rod made out of links of chain. It's the colder you make it, the more incapable of sagging and doing silly, stupid things that are not going to be good for walking, or however you want to look at it. It's a tight rope versus a loose rope. A tight rope you can walk across. A loose rope, a saggy rope, you don't have any hope. Probably are more perfect analogies, but a road with potholes, a road without potholes. That's pretty simple, right? You can sort of get that. You can go a lot faster on a road without any potholes in it. And your car works better. And you lose less speed to friction. So you can not only can you go faster, but you can go faster for two reasons. Do have to get used to this thing. It does cause a bit of a choke now and then. It's just so easy. It's just so light. Very much like a cigarette. I mean, in volume and feel. Pretty much. Weird shape, though. Triangular, diamond shape. Back to this one. A little smokier. Anyway, that's probably enough. Is not saying much, so we'll give you another minute to save the room with a profoundly interesting observation. Wonders why silver is the best conductor at room temperature. Let's see. I think why would that be? Well, gold certainly is better. So you're saying gold isn't as good at room temperature? Then why do they use gold in circuits and such? So I don't know. Wonders why silver is the best conductor at room temperature. So silver gets worse the hotter you make it. So silver, silver has a higher. I mean, they have a number where they measure how conductive something is, right? So silver is below gold, but apparently silver overall is somehow below gold. Well, I don't know how they do the test then, because then silver wouldn't be. I wouldn't have to make this argument. I have to look that up, I guess, because I just don't know why you would say silver is the best conductor at room temperature. Because shit, it's so much cheaper than gold. Why wouldn't they be using it? And it can't have, I mean, no. Yeah, well, silver doesn't corrode that much either. I mean, silver doesn't oxidize that rapidly, and the oxidation is trivial. I mean, superficial. So I don't know how that would almost, in my opinion, make silver preferable for some causes, just because you got less chance of shorts and a lot of other things. Yeah, I know, but we're not talking about gold contacts. We're talking about gold being used on circuit boards, for example. So yeah, I mean, and then gold on contacts. Gold is so much softer than silver that why would I choose gold to put on a contact? Because contact by definition means physical impact, which means the gold will get, gold plating is notoriously easy to rub off. So I mean, it's like gold plate is not nearly as durable, and certainly on contacts, it wouldn't last long at all. So I don't think that makes sense. I don't know what a Julie is, but I don't know. I guess it's one of these. I mean, they have different names. So this one's a PHIX, a fix, and this other one was called Infin Infin. I don't know. You can't even pronounce this shit. INFZN. So apparently they might make the pen too. I don't know, but their cartridges fit the pen, even though they're made slightly different. They fit. So I guess everybody's making things to the standard, but I don't know how many people make the pen itself. Maybe it's not, maybe it's not patent pended or whatever. So everybody's copying it or something. I don't know. All right. Used as a method for heat conduction in a grease medium. Best conductor of heat. I don't know what that means. So you're saying gold is the best conductor of heat. Silver has too many uses than gold. Silver has too many more uses than gold. It still doesn't make any sense. I'm just saying, obviously, it would be a lot less expensive to use silver on circuit boards than gold. And when they really want to count on a circuit board, they use gold. No. I mean, the other thing is most circuit boards are coated with a thin coat of lacquer. So any corrosion problem would be meaningless also. Well, I think it only kills some microbes. So that's the catch there. But most metals will kill microorganisms. Yeah, well, I mean, arsenic will, disinfect water too. But you wouldn't want to drink it. I mean, obviously, people eat gold for fun, just to say I ate some gold. But I mean, obviously, gold isn't as big a problem as it doesn't combine with a DNA molecule, where other heavy metals do. But who needs to get into all this crap? This is a little bit far of the field. Make some valuable shit. I don't know what that even means, but whatever. Whatever. I don't know what all that crap means. I don't know what this whole slide of reasoning is worth. The only part that I get out of it that's all interesting is just I was just thinking about, in a couple of video goes, I talked about how electricity is traveling on the outside, and I think that's horseshit. The electricity has to travel through between the atoms, and that's why it matters what the atoms are made out of, because the electricity has to actually travel through them, and how well they line up is really important to how well the electricity goes through. So some metals are innately more lined up than other metals in terms of the atoms creating a grid work, not a matrix, whatever the right word is, of roadways, so to speak. Oh, make some valuable shit. It was a joke. Is it the levels of the electron shell configuration? I'm not a big fan of the word shell, but obviously the electrons, the more, if you have two round things, you could sort of understand that if current is going to travel, that is, the pressure between things is going to travel, it might be best if they travel between the atoms this way. Okay, so an electron here and an electron over here have force between them, and that force gets pushed, so to speak. This electron pushes, that pushes this electron, and that pushes the next electron, that pushes the next electron, to avoid getting caught up going through the atoms. So I guess the interesting thing would to see how much, how slowly current travels through different conductors might be an interesting way to gauge the path the electricity is taking. But again, it's this time problem, because it's also the size of the atoms, how many atoms you have to go through. So the smaller the atom, the more atoms you have to pass through. That means the more electrons you have to move. So you're talking about the density of the electrons per volume will tell you something. The density of the atoms per volume, in my opinion, will tell you something about that transmission speed, because you have to go through more electrons theoretically, the smaller the atoms. So that might be a way of I mean, doing some research on that might be a way of indicating how well something will transmit a volume of current. One could argue that the smaller the atom, the more substantial the heat problem in terms of how much it's going to move the whole atom, transmitting the current, the more it's going to affect the nucleus. So the denser the atom, the tighter, the more likely you're closer to the protons when you're doing this current moving. And so you're having more of an effect on the nucleus, therefore causing photons to be broken off. Yeah, I think that's pretty good. I'll have to look into that someday. Write that down. Another day of work to do. So many things to look into. Electron, I don't even know how to say it, so I'll know what the hell I'm talking about. Electron pressure, size of atom, in current efficiency. I might know what that means 2 months from now. If I even, I have to look at this piece of paper 2 months from now. See if I even do that. It's just so much that hasn't been done in physics. It's so underdone. All this billions of dollars they spend on all these complex experiments, and if they'd spend a little bit of this time just doing the, bread and butter kind of shit. Let's see. I would make a stator wound with, I don't know what that is. Silver. I guess it's silver wire instead of copper to test the motor. Yeah, well, that's just expensive, I'd imagine. So, I mean, I've never even. I mean, I guess they use it in jewelry. You can get some pretty good wire for jewelry that might be pure silver, but it's even hard to get pure silver. You know, they always taint it with something. you know, um, but yeah, I don't know. I don't know how much it could possibly make a difference in a motor, for example. I mean, you're just talking about tiny increases, probably in efficiency. I guess it's obvious they're tiny increases in efficiency, or we have a bunch of silver inside of motors, kind of obviously. Electric car may be a significant difference in heat losses. Yeah, I just find that doubtable, especially a motor that's doing a lot of torque. I would think you'd almost be better off using steel wire or something. You know, you'd almost be better off just making the wire thicker, you know, if you can. But yeah, I just don't think it would do you much good. Yeah, I don't think a coating could do much for the actual transmission of the electricity as I'm thinking about it. Like I said, I just don't think I've never really seen coated wires used. It's like the transmission lines out here on the road, you know, they're carrying the 16,000 volts. Um, it looks like aluminum to me. I mean, it's definitely not copper. Um, so there might be an alloy, but it is bizarre. I mean, it's only this quarter-inch thick wire, you know, and it's the amount of current that's going through it is insane. Because I've seen them shorted, you know, and it's a plasma it creates. I mean, it's just an intense amount of electricity going through this wire. Um, so, I mean, it's, you know, obviously this voltage thing is a huge, you know, increasing voltage is a huge advantage in terms of increasing current. Wattage, whatever the right way to say it is. Um, because, you know, if you tried to pump 12 volts through that wire at the same output wattage, it would melt in a second. I mean, it would just disappear. It would just it would be gone in a millisecond. So that's part of this whole thing is what kind of obviously you can't use too high a voltage in a motor wound unless you insulate the wires. You know, they just coat them with, like I said, you know, some sort of plastic coating. You know, just spray paint them, and so the wires are right next to each other, but they have an insulator of a thin coating, a thin clear coating, a clear coat, you know, an epoxy, whatever. What do they use? They use something really simple, like varnish or something. So they varnish the wires and then wind them, and um, so obviously you can't go very high voltage with wires that don't have any distance between them or insulator between them. But obviously there's a huge advantage in increasing voltage in terms of reducing heat. We don't even have fire hydrants on our street. I mean, we don't have public water. So, I mean, I've watched houses burn down in this neighborhood, so to speak, just because there's no water, And we're up on a hill and there's a stream that's, a couple of 100 feet below us, that isn't very far away. It's only a few 100 yards away, but it's so much hill that they can't pump the water quickly enough out of the stream to get it to, never works anyway. I've never seen them successfully pump the water from the stream to pour it on a house. So by the time they get it working, it's way too late. So that is an interesting, but anyway, yeah. So it is funny if, I mean, even the landlord here, I don't know why. I mean, I've suggested a few times at different points, there's like, maybe we should have a tank just in case, something catches fire. Anyway, Michael Van Breezian is one of my favorites to teach traditional physics on YouTube. Yeah, I like him. That's why I'm subscribed to him. But he is full of shit on some subjects. He's just one of the, board, and he just talks the shit. And that's all disappointing because it is shit, And he should call some of it out because he knows better. I mean, I think he knows gravity isn't the same shape as, the lens isn't the same shape as a traditional magnifying lens. That you're not going to be able to magnify anything with any kind of shape to it with the wrong lens. I think he knows that. Yeah, well, see, high voltage, I think the reason why it's more efficient is because it's the argument is that the current moves by jiggling electrons, by this moves and then this moves. The electrons move magnetically. So kind of the argument is the higher the voltage is, that means the higher the pressure. This means you're moving this faster. And so it's like magnets, you're jabbing into them. And so the process of the moving is happening faster, and the movement itself is frictionless, so it doesn't cost anything in that sense. So in some obvious ways, there's greater efficiency in moving things quicker than to move them slower. It's like if there was to be a drag issue of some kind or any kind of friction, you're eliminating more and more of the friction the faster you push the thing. So it's like you want to jump a gap, the slower you go, the more likely you are you fall inside the hole. Faster you go, you'll be able to go right across it, kind of argument. Because I'd argue that voltage just means pressure, and the pressure is what's between the electrons. So as you're increasing the voltage, you're increasing how close the electrons are to each other. So you're basically just saying, instead of having to move this, this, you're just doing this is just doing this little distance. And such. All right, well, I guess I've dragged this out probably long enough. Amperage is the flow rate. Yes. I mean, obviously, voltage is the pressure. Amperage would be how many little things pass the given point. So you're really just saying, one thing is saying, let's see, how is a better way to say it? Because it's electrons. You always have to remember it's electrons. How much, how many electrons you're moving would be amperage. That's probably why amperage does more damage at lower voltages. When you have to increase, if you lower the voltage and you want the same output, you have to increase the amperage. And so the amperage would be you're affecting more electrons. And the more electrons you affect, the more heat you're creating, because there are atoms that won't be really in the mood. You know, you're having to force atoms that don't want to conduct the electricity to conduct the electricity, maybe. And therefore causing more heat. Something like that, maybe. Higher the voltage, the less electrons you have to push. Might be a good way to look at it. And the lower the voltage, the more you have to affect, and that means the higher the amperage, the more electrons you have to engage in the process. Professor Lewin covers this in one of his lectures in the equation creation. You have to square the amps. Yeah, well, I'm not sure. There seems to me to be a pretty close to one-to-one relationship between amperage and voltage and wattage. So I'm just saying I don't, obviously, I think they're already correlated to some extent. I mean, if I take a 100-watt light bulb and I put 120 volts into it, it's going to be essentially 1 amp or 100 watts. And if I make it 50 volts or 60 volts, cut it in half, then I go up to 2 amps. So, I mean, it seems to be a one-to-one relationship pretty clearly. I mean, the what do they call the what's the word for the designation of an amount of something? Oh shit, I can't remember the word. But it's already translated. Essentially, volts have already been correlated to amps and watts. So, as quantities, as measurements of something, as volumes, as what's the word I'm looking for? Anyway, it doesn't matter. There seems to already be a relationship that's pretty coherent. Yeah, the water analogy works in a lot of ways. I mean, clearly it breaks down, I guess, in terms of issues like speed and let's see. Obviously, it has only this idea of a surface friction, inside the friction of the pipe, instead of friction going through a porous substance would be a better way to look at it. There's lots of places where the analogy would break down. But yes, obviously it's been used as an analogy because, I mean, that's how Benjamin Franklin was sort of talking about the movement of charge was as a fluid. But the other point to that is that they're not. There is a difference between the plus fluid and the minus fluid kind of argument. In a 12-volt solar panel, you need roughly 10x as many amps for running 120 volts. I'm just arguing that clearly the amps are correlated, and the point is the wattage is what you're getting out. That's the net quantity of energy. So it's a watt, and a watt equals amps times volts. So I'm just saying you can say shit like you need 10 times as many amps. I don't think you do. So, fuck you. A 1 amp motor needs a 10 amp solar source. Yes, if you're converted to 120 volts, that's 10 times as much. So, of course, you need 10 times as much if you're going to convert it to 120 volts. So, if you're going to turn 12 volts into 120 volts, then yes, that's 10 times as much voltage. So, you need, you know, 1/10 the amperage for the outcome watts, which would mean you need 10 times as many amps at 12 volts. So, again, it's just a one-to-one correlation. I mean, you're not. Yeah, this is I'm just saying this is obvious, okay? Volts times amps equals watts. I mean, this, it's not that complicated. Lower the voltage, you have to increase the amps. I mean, shit. Lots of loss in conversion, though, DC to AC. Yeah, I mean they're making better ones, but I don't know exactly. It's technically, this seems like a technical problem they should be able to overcome eventually, but it is kind of strange that just throwing this frequency onto something obliges there to be this waste. I guess I think I would make inverters that had big capacitors in them, you know, and it just seems to me that if I create a secondary source with the capacitors, that I should be able to create a frequency from the original source versus the capacitance source where I would have less losses through the transistors. But that's the trick of it, is the transistors is where all the loss is. So the silicon isn't too perfect at doing high amperage transistors aren't very efficient. I mean, that's why computer chips run at 3 volts, 1.5 volts, tiny voltages. They got to try to keep the amount of electricity they're shoving through the silicon as low as possible. But it is something that's another sub place where if I was to work on something, if I had a little electronics room to go play in, those are the kind of things where you'd say, there's got to be a better way. There's a lot of inverters don't even create very good AC. I mean, it's pretty choppy looking. I almost think they could create one with a mechanical process too, where you actually have a little spinning motor inside the inverter, that creates the 60 cycles. Seems like that would be more efficient than the transistors. They make the inverter now right off the solar panel. I don't see any point in that, frankly. I just think there's lots of ways to utilize the 12 volts that you can get. The 24 volts maximum that you could get off of a solar panel, and you might as well just use the DC current to light lights and stuff like that. So I would just run a lot of stuff. I would just look, most of the stuff, all your electronics don't use AC, so it seems like you could recharge your electronics. Obviously, lots of things you could do where you don't need to convert it into AC. So you just leave it as DC voltage and don't waste any of it on inverting. I mean, I have a couple of solar panels, and the problem I'm having is the charge controller isn't a brilliant piece of crap, because it's not. I'm having a problem having it charge the battery at the same time. It's utilizing a load. And I'm also having, and even when I just have it charge the battery, I'm not sure it's charging it at the right voltages. So anyway, it's been a little buggy. It's working, but it's just, I don't think I'm getting anything close to peak performance out of it. I mean, the batteries in here were solarly charged. But you can buy them so cheap from China. I have like 5 different solar inverters. I mean, charge controllers, and they're basically DC to DC converters. They take any voltage DC in and turn into 5 volts out or 12 volts out, which is nice. Or the 15 volts to say charge a battery or whatever. But yes, $3, and and it's got USB ports on it. $3. It's just so cheap. So, okay, well, you kept the room alive. So it's electricity is a really good physics subject. So good work there. Let's see if you have anything else. All right, maybe time to go. I have to come up with a closing song. PHYSIC. S. Physics sucks. SUCKS. Physics sucks. Yes, it sucks. It's so full of shit talking bullshit. Let's see. Atoms in the void. I don't know what that means. It must be another shit joke, right? Let's see. Atoms in the void. Not really a void in the first place, right? It's full of a bunch of photonic pressure. And so the atoms aren't really voiding. They're sitting in a bunch of crap, flows of crap. And they will tend to move in some direction as long as the universe, as they look upon it, has some imbalance in it. They're going to be compelled to move with the imbalance and such. Bent void. Yeah, exactly. I mean, it's just everything you do with it. It's just, I mean, it's, it's like having, no penis and talking about how big your erection is. It's like, I have a 10-inch non-existent dick. Yeah, what? Huh? What? This doesn't make any sense at all. I mean, they ought to just say angels done it. I mean, it just isn't any different, right? When you just blame a non-existent nothing thing that is somehow maladjusted, the maladjusted nothing. I mean, you might as well just say boogeyman, right? I mean, the maladjusted nothing. That sort of sounds like the boogeyman, right? Just dropped in. Well, whatever. And a little left out. We'll catch up soon. Well, this won't be that soon, frankly. I mean, it's going to take you. I mean, I know you can accelerate the video to maybe twice its speed, but I mean, there's a point where you won't be able to comprehend anything that took place. So I don't think you can catch up that quickly. You know, I'd have to talk really, 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 really slowly for you to catch up. And I probably won't do that except for doing it as a joke and such. But it does remind me again of this speed differential between this pressure and any of the velocities we actually travel. So if there's drag in the universe, wouldn't the drag be infinitesimally small at the tiny, tiny, tiny velocities we travel compared to the speed of the pressure? Oh no, please carry on. We'll listen quietly. Well, I'm pretty done carrying on unless somebody does something like besides listening quietly. Listening quietly isn't very interactive. So I'm just saying I'm sort of in the you have to give me something for me to give you something phase of the video. So if you don't feed me, I'm going home. You know, it's time to pay the bill. You know, gotta pay me to play. And the currency is you have to say something smart and intriguing and interesting. That's the cover charge. Anyway, I'm stayed on longer than I thought I would, so it's probably time to go. It's well over an hour, so blah, 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 and I will go now. Unless somebody types something really quickly. 10, 9, 8, 7, 6. I thought the fart guy might show up. I'm very interested in Lesage gravitational theory. So it should be Fadio, okay? Lesage is just redoing Fadio. Does it appeal to you without any alteration? Well, you're way, way behind. I have made 1,000 videos on this channel on this subject. And frankly, you're just, you know, there's overview videos on my channel page in a playlist. There's only 3 of them, I think. Just watch one of those and you'll get the idea that yes, of course, I'm arguing for Lesage gravity in this end, but I'm calling it something. It's made out of actual photons, bits of stuff moving the speed of light. And those same bits, when at a frequency that's light, and those same bits, when filtered, that is, they have black bits and red bits in the field. And when they're filtered by electrons and protons, which are the magnetic monopoles, when they're filtered, they become magnetism. And so the same things, that's why they all move the same speed, is because they're all the same thing. Light, magnetism, gravity, all the same little quanta, just in different configurations, different arrangements, but identically the same thing. So yes, it's Lesage plus unification. So it's Fadio, Lesagerized, and then unified into perfection. It's all really quite, it's so simple. You'll all feel so humiliated when you do the finally accept it into the Eureka thing. You're just going to be like, oh yeah, it's so simple. Why didn't they figure this out 1,000 years ago? I mean, obviously they had some challenges. You know, they hadn't invented light bulbs yet, and they haven't done a lot of things. So, all right, why didn't they figure this out 100 years ago? Einstein wasn't an imbecile. He really should have been able to say, oh, wow, yeah, that's a much better idea than my silly bent void magic penis theory. Let's see, gravity is the same speed as light photon? Yes. Yes, it's been measured. Can't we detect the sun's gravitational pull instantaneously? Not even close. No, they've never detected anything instantaneously in the history of the word instantaneous. There's never been an instantaneous experiment conducted ever to measure the instantaneousness of anything. It just can't do that. But anyway, while it takes light 8 minutes to get here, right? And it takes gravity, the deficit in the gravitational field, the shadow, moves exactly the same speed. I mean, it's just a shadow. Gravity is just a shadow, and it moves just like the shadow of light. It takes time to get someplace. So just like a light shadow takes the speed of light to get to a location, a gravitational shadow takes exactly the same amount of time. That's in Einstein's math. So, I mean, that's frankly, that's already a given. I mean, the reason why Einstein's math is better than Newton's math, one of the reasons, half of the difference in accuracy is merely because Einstein did the calculations based on gravity moving the speed of light. So when you do the calculations with gravity moving the speed of light, they're they're more accurate. So I'm just saying it's sort of a proven more than one way that gravity is moving the speed of light. The proof is in different forms, but one of the most obvious proofs of it is that Newton's math is more accurate if you have the force move at the speed of light. The speed of force, actually. It should be called the speed of force because all the main forces move at the same speed. That's what Maxwell found out. Nobody seemed to get the right, nobody got what's obvious when they figured out that magnetism, hey, it's the same speed as light. That should have told them something, and it somehow they missed the obvious. Light is just a force. That simple. It's just a force. Only has reality in one dimension, the dimension it's moving. That's it. It's a one-dimensional object. Is there or can there be anything faster than light? Well, I'm just saying the can thing, I can't. I obviously would tell you if you had 10,000 bucks and there was a stock to invest in that was, we're going to find something faster than light, I would advise you not to invest in the stock because I don't think it has any chance of ever happening. So I think there's zero chance that anything's moving faster than light. Zero. And so uh, obviously they haven't measured anything faster, so they'll never, and I just don't think they ever will, and it's just stupid to think so because photons really are gravity, photons, and magnetism, the virtual photons of magnetism. Those are all the same thing, and they're the smallest stuff in the universe. There are no neutrinos, there are no other little bits. Those are the bits. That's it. There isn't any other forces. They're the only things moving fast, and they're all moving the same speed. Nothing else is going fast. Okay, and nothing else is challenging their speed record. So if they detect something called a neutrino, they're detecting gravity, magnetism, or light, but they're not detecting a neutrino. So photon, gravitation, graviton, photon, graviton. Well, let's see. Using the word graviton just is a non-starter for me, just because conventional physics thinks a graviton is some kind of gluon. They think it's some kind of bubble gum or something. So it's just you can't really use the word graviton because they don't think of it. They think of it as a wavicle, not as a particle. All right, and electron. Electron is completely different. Electrons are three-dimensional objects, big, heavy things by comparison to a photon. Electrons never go the speed of light. Just never happens. If it even looks like it is, it's just because it's two electrons are bumping into each other and moving. They can do this very fast, but they'll never move an electron the speed of light. That doesn't happen. So electrons can go fast. They just can't go the speed of light. All right, are all the same speed. So again, electrons have nothing to do with this conversation in a sense. Electrons are the first matter bit. They're the smallest matter bit. The graviton, the photon, and the magneton, or if you want to call them those, if you want to use that kind of language, the photon, the photonic energy, the gravitational energy, and the magnetic energy, those are all the same thing. They all move the speed of light. Electrons and protons can be pushed by that force very fast, but they'll never go the speed that the force is going. All right, just vibrating at different frequencies. And vibrating is just, it's not even worth thinking about, worrying about vibrations. It's obviously things, the matter bits are in tension. So they're always moving in tension. They're always getting hit by stuff, but it's usually equal amounts of stuff. So they are just going like they're in tension, magnetic tension, gravitational tension. They don't vibrate on their own. They vibrate because the field moves them, vibrates them. The Brownian motion is not inside of the electron or the atom. The Brownian motion is in the field jostling them. All right. There is the theory of quantum entanglement. Hasn't it been proven yet? I'm just saying they claim they have experiments, but I'm just saying the experiments are so assumptive and so thin. I mean, they're saying there's a talking elephant, and what they'll show you is there's a black box. We put some steamer trunks in it, okay, and we put some big giant toenails in it, and we put some other bullshit that almost might be an elephant. And then we shook the box, and we heard the box go, ow, 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 ow. And so they say that's a talking elephant. I'm just saying the evidence is putrid, not even close to something anybody rational should accept as proof. So it's like me saying somebody's guilty of a crime by just walking into court and saying, look at his hair. Isn't it obvious? He's guilty, right? When he was 16, he kissed a girl without permission. Doesn't that prove he killed his wife? I mean, it's that bad. The evidence is putridly thin. And so, yes, they're never going to do this. There's no entanglement. The little photons don't pop out and go, I'm telepathically communicating with you, blah, 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 blah. Oh, I can still talk to you. Oh, can you hear me? Can you hear me now? They're photons, for fuck's sake. They're the simplest dumbasses in the universe. And they're giving them more function than our aircraft carriers. I mean, they have more features somehow than the most technically advanced thing we can create. They can instantaneously communicate with each other. I mean, come on. Absolute steaming, made up baby talk. I mean, it's worse than a Three Bear story. I'm saying that, yes, by their theory, a graviton is not a discrete particle. By their theory, if there was such a thing as a magnetron, whatever, it would not be a discrete particle. They're virtual particles. Even when they call them virtual particles, they give them wave properties. Okay, they make them wave even though they're not waving. There's no evidence that they're waving. It's the de Broglie thing. They think a fucking electron is in a wave. They say because it has a speed and a mass and it's moving, that it's waving. So when a car goes by on the road, by their theory, the car is waving at 60 miles an hour. Okay, it's not just moving 60 miles an hour, it's somehow waving at 60 miles an hour. It has a frequency. So even though it has no detectable frequency, right? The car has absolutely no detectable frequency. They will claim that it has a frequency that they can put into their equation and that their equation will tell them what the power of the car is based on its frequency, when all they've done is correlate some notion of frequency to velocity. And of course, you can do that if you want to make frequency have intensity. But see, as I've argued, bullets fired from a gun do not have variable intensity. There's no such thing as a strong bullet and a weak bullet coming out of the same gun. All the bullets are the same. Now, if I fire 10 bullets a second, or I fire 1 bullet a second, obviously you could argue, well, the 10 bullet stream is a lot more intense. Yeah, there's a lot more bullets in it, but the bullets aren't more intense. They're not going any faster. There's just obviously more bullets per a moment of time. And so this is how they've so perverted even their own math, where they've correlated volume and momentum to a frequency. And so they're using frequency as a catch-all for volume and momentum, when it's not. It's not the catch-all. It's the byproduct. It's the thing that emerges from function. The actual function of momentum has nothing to do with the frequency. The actual function of momentum just has to do with distance and mass. Moving mass a distance takes energy, and a specific amount of energy required to move it. The fish in a school of fish must swim a certain speed, okay, in a direction for the school to move. They've turned that into a wave property, and it's not a wave property. All right. Visual particles. I mean, I don't know what you're doing. Visual particles. Clearly, all of these little bits aren't visual. Can you explain how to understand that concept? I'm saying, if you're saying visual particles, I don't know what that means. Do you mean light, the visual spectrum? That means particles at a specific frequency. Well, what do we know those things hit? What do photons hit? They hit electrons. So they excite the electron, they vibrate the electron, they hit it at a certain frequency. So I've explained this 7 million times, but it's a tipping point argument, or it's a pressure argument. So say something's sitting on a mattress or a trampoline, and I hit it once, and it goes down and pops back up. You can sort of understand there's a certain amount of time it'll take for the rebound, right? So then if I hit it twice, okay, but I let it rebound, and then I hit it again, and I let it rebound, and I hit it again, and I let it rebound. Well, nothing's going to happen. Nothing new, nothing different. But if I hit them quickly enough, that is, I hit it, and then while it's still down, I hit it again, then the rebound is going to be twice as energetic, right? It's going to be, or 4 times as energetic, because I've increased the pressure, and now this is going to fly out. So clearly, frequency matters to electrons in tension. Tension can be affected by frequency, and you can break the tension. But that has nothing to do with momentum or absolute energy. Okay. Visual particles. Just very strange. Anyway, I think I've answered your question. An artifact of the limitations of instruments measuring above the scale of samples being measured is obviously you can't measure something big with something bigger. I mean, you can't measure something big. You always have to measure something with something smaller than what you're attempting to measure. If you throw bowling balls at baseballs, you won't see the baseball. Okay, just won't. You have to throw baseballs at bowling balls to be able to get some feedback. some useful information back. You won't get useful information throwing big things at small things. Waves are an analog only meant to describe a probability distribution. Well, I'm just saying the half the waves they are saying are just a made up factor, but clearly they're implying actual waveness. So let's not pretend they aren't using the word both ways, and you'll never know in any context what they mean by the word wave, whether they mean, oh, this is a fake placeholder for something that happens over a period of time that we, through our own perversions, can convert into an energy equation over a period of time. And we'll call it a wave, even though it has nothing to do with anything actually waving or vibrating even. All right, but anyway. I mean, clearly the probability distribution is like me switching a light switch on and off. It's not, I'm not waving. And you can figure out that if I'm switching it on and off once a second, there's no wave involved. There's motion, energy in one direction and energy in another direction. There's no thing called a wave happening. So that was useful. Thank you for this. Do you know when you will be live again? It happens every day or two. Sometimes at night, sometimes during the day. This Saturday thing I try to keep doing reliably, but yeah, who knows. But anyway, yeah, I wish I could do a regular schedule, but my life just won't permit regular schedules. So you can still prepare ahead of time, and then if you get into a room, then you'll be ready. So that's fine. But yes, it's either going to be, it's usually going to be in the morning, so around 10 a.m. Eastern Standard Time, or it'll be midnight Eastern Standard Time. Those are usually the two times that are most convenient for me. Sometimes I do it in the afternoon, but most of the time it's one of those two. And most of the time it's at night. So it's midnight Eastern Standard is 80% of the rooms, I would say, are midnight Eastern Standard Time. Or 11 o'clock, I don't know. Well, whatever, something between 11 and midnight. But yes, maybe when the winter kicks in, I'll be able to get into a better habit. But just don't say, just my life is too much bullshit going on. So now I think we've done 2 hours. So exceeded my expectations. I will thank the participants. You did pretty good today. I'm very proud of you. Thank you. Thank you. Some reasonable questions on topic, sort of, at least useful topics, interesting topics. So this is the way I would like the room to go. And if there's any of you who would like to engage me personally in this room, interrogate me on my theory in some way or whatever, I am willing to do that also. So anyone who has any kind of physics knowledge and wishes to interact and force me to explain why I think it's all rubbish and such, certainly interested in being educated. Okay. On how great your evidence is for what you believe. Anyway, so till the next time and such, thanks and such, and blah, 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 and such.